This is your review for your radicals and radical functions test with rational exponents. Number one asks us to rewrite the following in radical form. Okay, we don't have to try to find the answer, just rewrite it. So the 5 over 3. So remember, our bottom number is our root and the top number is our power. So this is going to be the cubed root of 2x plus 7 to the 5th power. 18 to the 7 over 9, so our root is 9, our power is 7, so it's the 9th root of 18 to the 7th. And 4x minus 3 to the negative 3 over 4. Anytime you have a negative exponent, that means to take the reciprocal. So I'm going to have 1 over, and then it's the 4th root of 4x minus 3 to the 3rd power. Rewrite the following in rational exponent form. So 2x minus 5, and the square root is the same as the 1/2 power. 2x minus 7 to the 3/5. 3 is our power, 5 is our root, and 2x minus 7 to the negative, because it's in the denominator, 4 over 7. Evaluate the following. So I have 25 to the 3 over 2. So that's the square root of 25 cubed. The square root of 25 is 5. 5 cubed is 125. 36 to the negative 1/2. So negative exponent means take the reciprocal. The 1/2 is the same as the square root. Square root of 36 is 6, so I have 1 over 6. 8 to the 4 over 3. So that's the cubed root of 8 to the 4th power. Cubed root of 8 is 2. 2 to the 4th is 16. 1/8 to the negative 2 over 3. So negative, take the reciprocal, so that's 8 to the 2 over 3, or the cubed root of 8 squared. Cubed root of 8 is 2. 2 squared is 4. Number 4. For this question, let g of x equal 4 root of x minus 3 minus 8. So our domain, okay, I'm going to go ahead and graph this function. So I know that it went right 3 and down 8, and it has a vertical stretch of 4. So right 3, that is where I know that from. Then I'm going to move it right 3 and down 8. Okay. Now normally my square root parent function goes through 0, 0, square root of 1 is 1, square root of 4 is 2. This has a stretch of 4, so instead of going over 1, 1, it's going to go over 1 and up 4. And instead of going over 4 and up 2, it's going to go up 4 times that amount, so over 4 and up 8. And I can't take the square root of negative numbers, is not real, so I'm not going to have any points to the left or underneath it. This is where it's going to start at. So our domain are our possible x values. So the farthest left that it goes is this 3, so it's going to be 3 with a bracket, and then it goes to infinity. The range is from the bottom of it. The bottom of it is down at negative 8, and then it goes up to infinity. Solve for g of x equals 12. So we're going to set this function equal to 12. So 12 is equal to 4 root of x minus 3 minus 8. So I'm going to add 8 to both sides and get 20 is equal to 4 root of x minus 3. Then I would divide by 4. 5 is equal to the square root of x minus 3. Then I'm going to square both sides. So 25 equals x minus 3. Add 3. X equals 28. You can always plug this back in to check. 28 minus 3 is 25. Square root of 25 is 5. 5 times 4 is 20. 20 minus 8 is 12. So that works whenever I plug it back in. Find the coordinates of the x-intercept. Well, the x-intercept occurs when it crosses the x-axis or when y is 0. And that happens right here at 3, 4, 5, 6, 7, 7, 0. We've got our graph, and we're finished with this problem. Solve the following for x. Alright, so the cubed root of 2x minus 1 equals 5. My radical is by itself, so I'm going to get rid of the root by cubing both sides. And that gives me 2x minus 1 equals 5 cubed. Now 5 times 5 is 25, and 25 times 25 times 5 is 125. Then I'm going to add 1 to both sides. 2x is equal to 126. Divide by 2. X is equal to 63. Always plug it back into check. 63 times 2 is 126. Minus 1 is 125. Cube root of 125 is 5. 4x plus 1 to the 4 thirds. Now remember, whenever you have a rational exponent, a fractional exponent, you have to raise it to the reciprocal. So the reciprocal of 4 over 3 is 3 over 4. So I'm going to have 4x plus 1 equals 81 to the 3 over 4, or that is the 4th root of 81 cubed. The 4th root of 81, the number that multiplies by itself 4 times to give us 81, is 3. And 3 cubed is 27. Then I'm going to subtract 1. 4x is equal to 26. Divide by 4. X is equal to 6.5. 6.5 times 4 is 26, plus 1 is 27. Cubed root of 27 is 3. 3 to the 4th is 81. So that works when I plug it back in to check it. Find the domain of 4 minus x squared. Okay, so we know that we can't take the square root of negative numbers is not going to give us a real number answer. So 4 minus x squared has to be greater than 0. So I'm going to find out when that's greater than 0 by subtracting 4. That gives me negative x squared is greater than negative 4. I'm going to multiply by negative, so that gives me x squared is less than, because I've got to flip my inequality, 4. Square root both sides. X is less than square root of 2, but it's got to be positive negative 2. Okay, so looking at this, okay, so if it's got to be between 2 and negative 2, because if it were 3, 3 squared is 9, 4 minus 9 is a negative number. That won't work. So my answer has to be between 2, and this is greater than or equal to, sorry. Negative 2 is less than or equal to x, which is less than or equal to 2. That needs to be greater than, that needs to have an equal sign underneath, because we can take the square to 0 and give us 0. So those are my answers for that. Now my range, the y values that I'd get out. And this is something that may be easier for you to look at on a calculator to graph it and look. But thinking about if I plug in negative 2, that would be 0. Square root of 0 is 0. It can never be below that. So 0 is less than or equal to y. And this is going to be at its highest point halfway between negative 2 and 2. So when x is 0. So the square root of 4 is 2. So 0 is less than or equal to y, which is less than or equal to 2. Again, that's something that's maybe easier for you to look at the graph and tell it from the graph. But you can also do that algebraically. Number 3, write a radical function with a domain from 3 to infinity. So that lets us know that it moved right 3. A range from negative infinity to negative 3. Okay, so we know it went down 3. We also know that it flipped over because this is a negative infinity, so that's an x-axis reflection. And a vertical stretch of 2. So y equals the square root, has a vertical stretch of 2 and an x-axis reflection. So I'm putting a negative 2 out in front. I'm going to have x to move it right 3. I'm going to have minus 3 on the inside. And to move it down 3, I'm going to have minus 3 on the outside. Number 4, write a radical function with a domain of 7. So this one moved right 7. Range from -5 to infinity. So this one hasn't been flipped. It has moved down 5. And a vertical shrink of 2/3. So I'm going to have y is equal to 2/3 square root of x minus 7 minus 5. Solve for x. So I need to get the cube root by itself. So I'm going to add 1 to both sides. So that gives me 3 times the cube root of x plus 4 equals 6. Then I need to divide by 3. So the cube root of x plus 4 equals 6 divided by 3 is 2. Then I'm going to cube both sides. So x plus 4 equals 2 cubed. 2 times 2 is 4 times 2 is 8. Subtract 4. X is equal to 4. Remember to check your answer. 4 plus 4 is 8. Cube root of 8 is 2. 2 times 3 is 6. 6 minus 1 is 5. And that is it for your review.